Good day, ladies. Heartily welcome to this session. In this session, on the previous session, it's the geometrical constructions part 1. This one is geometrical constructions part 2. Since we have to level up, we change this to a more difficult level. But if you know the principles and if you understand the sequence of how things are happening, you will be perfect with this. Now, of course, I am not using my compass, but you will see if I strike an arc, for instance, the arc will roll down, and then also drawing lines will be rolling out. It's not going to be just snapped to a line, so in most cases. All right, so the principles will be explained to you as we carry on, and I hope you will understand it after this session and see what the principles are for that. Now, if you go to the first slide with geometrical constructions, they're giving you this these two lines, saying to you that you 20 millimeters apart from that you have to draw basically a fillet towards that part. In other words, you have to round it off on the sharp edge of that. That's most of the times what you will see at the table, for instance, where the table end was smoothed out with a curve or something like that. All right. In other words, you have to put a fillet in there, 20 millimeters from the side, so you can realize that if I put an arc on those ends of the lines, it must be 20 millimeters away from where the needle point will be. All right, so in other words, if I set my compass on 20 millimeters and I go onto the line itself and put my needle point of my compass on the line and strike two arcs on the line itself, which is horizontal, and also the diagonal line, two strikes of arcs that you will get there. And if you put a tangent line then parallel to those lines, you will know that if the distance was set to 20 millimeters, that tangent line will also be 20 millimeters. And at the intersection point of those two lines, you will be basically get the point where it will be 20 millimeters away. So if I keep my compass on the same dimension and put the needle point at the intersection point, I will be able to draw the curve or the arc, smoothing out or fillet it out towards those points that you see in that regard. All right, so now remember, fillet can also be 45 millimeters by 45 millimeters. In this case, the fillet is 20 millimeters, so therefore the arc will be rounded off by 20 millimeters. In this case, I've got two straight lines. In other words, those two straight lines just points out to you that again you have to put the fillet in there but in this case 15 millimeters. So the compass will be set on 15 millimeters, and I will strike two arcs on each of those lines in order to get to the point where I will say, all right, this will be 20 millimeters away. I can join those lines with a tangent line, and then where I will get my intersection point at this specific point over here, I can basically set my compass on 15, and then from there on it will be 15 backwards. So if I strike the arc from there up to that point, it will give me a smooth curve, and then I can draw the dark lines in. Now just take a look at the quality that I'm talking about. The final product must be an A line, and that we used to say it's the black lines in PowerPoint, but also the dark thick lines. And then the construction lines, those are the green lines. In other words, if you're an arm length away from the drawing itself, it means that you must struggle to see those lines. It must be very light. Use the weight of the pencil in drawing those lines. And then the blue lines, that was the question, or in this case the next question over here. You can see it's just given to you. You have to work from that point further onwards. Now in this case it's asking for 22 millimeters, so setting your compass on 22 millimeters, and then put the needle point somewhere on the line, and then just draw two arcs on the horizontal line and also the diagonal line, two arcs over there. You take your compass and you take your ruler and you draw a tangent line towards that. You can also slide, in this case with the horizontal line, your T-square up to that point. But it's very important just to make a small little portion of contact with each arc towards the line itself. All right, and then I will create myself the intersection point, which is 22 millimeters away from the diagonal line, 22 millimeters away from the horizontal line. And once I've got those 2 points, I can simply just draw the arc in and complete the rest of the drawing itself, which is the question. All right, geometrical construction on tangent to a circle. Now, what is a tangent? A tangent is basically then a line that will touch this circle only at a very small portion over here. Now I have to draw a tangent line from out here outwards, but now sometimes you can say for yourself, right, it's quite simple. Just take your ruler and take it from B outwards, and then if it's just intersecting with that point, you simply draw the line. Yes, it is, but remember the end product is basically one mark, but the process in getting there, by means of construction, the examiner is asking. He needs to see the construction lines of the way that you got up to that point. All right. So in other words, there's a engineering, graphics, and design method in getting to that specific point. Now let's quickly have a look. If I should join A with B, I will then from there on take that line and bisect the line. Now remember over the previous session, the part 1 of geometrical construction, the bisecting of a line was a part of that. Now this is applicable to this exercise itself. Since I've got the center point or the middle point of that line, I can put my needle point on that point, open up or stretch up my compass towards the point of B, or it could be A because it's perfectly in the center, and then strike an arc from B to A or from A to B, doesn't matter. Alright, now since I've got those points, you will see that I have got an intersection point on the existing circle. Alright, so if I draw that line up to that point, I can now say, alright, this will be the tangent line towards that 90-degree angle it will make at that specific point. Alright, so the long and short that I want to point out, the long and short of what I want to explain to you in this case, is simply then the process of getting that specific point, and that specific point will make the point of contact. Alright, now in the next case over here, where I want to point out to you, it's external common tangent to an unequal two unequal circles, or an equal circle. Alright, so this is what it points out to you. It's giving you two circles. Now the one is bigger than the other one. It's talking about an external common tangent. Now external, exit, means outside, means on the outside of it. So in other words, this tangent I have to draw, it should be on the outside. In other words, on the outside of that circle, on the outside of that circle. It can't be from outside to inside. It should be outside the distance between these two circles, or the space or the area of these two circles. Alright, so now first of all, with the previous example fresh in your mind, you will see that you will have to join A towards B. Now remember, with the previous example, it was just a point. In this case, it's a circle. It must go on the outskirts of the circle to the outskirts of the circle. Alright, on the previous example, I have to get the bisecting point, and the same with this one. I get the bisecting point. So there we go. Now I can strike an arc. So there's the arc over there. Now you have to take very care. I'm talking about an external circle. I do have got two circles, one smaller circle and one bigger circle, and I have to, in this case, to get to the point where I need to get the intersection point. I can't just use this one because I've got one on that side as well, and it's not in the same direction. If it was a bow, it should have worked out from there onwards towards that point over there. But in this case, it's not going to work if I just draw a straight line over there, because it's intersecting at that point and it's intersecting at that point, so that won't help. Now, external means outside, means big. So to prevent going off the paper, I have to subtract. I have to make smaller. Right now, so what do I make smaller in this case? I've got the big circle and I've got the small circle. Right, so in that case, it means if I subtract the big circle radius from the small circle radius, I will get a radius of 20 millimeters. So I set my compass on this 20, so that, in other words, I've subtracted this big circle from the small circle, got to 20, and from A, I will draw the small circle. There is the small circle of a radius of 20 millimeters. Alright, now I've also got an intersection point, and this looks more realistic if I should draw a line from this point to that point, that it will intersect somewhere there. So what I can do now is I can use that point at E, that intersection point at E, and from out A I draw a straight line up to that point. I call it F, take my ruler, and then from there on I'm going to slide a parallel line, parallel to this line, towards my other circle as well. Alright, so in that case I will be basically take it from there and I slide it all the way up to that point and also draw a line. Now I've got the two lines from out that part. Where did I got this part? That was minus big radius minus small radius. So that's the size of the circle, and this is the arc. I've got the intersection point, extend the intersection point towards the big circle and take it parallel down to the small circle. So once it's there, I can now take my ruler and it will work out perfectly in terms of where this point will be intersecting on that specific point. It will again make 90-degree angles over there, and it will make a 90-degree angle over here from this projection line towards my end result, my answer over here. And that's what you will get in terms of that. Alright, so what happens? It's external. External is large, so you can't go even more larger, so you have to become smaller, so therefore you subtract the big circle with the small circle. Alright, so that's the rule. Now I have to draw an internal common tangent to unequal circles. Same as what I have had on the previous one. The only difference is this one is internal. In other words, it should go in between, in other words, keeping these circles on the outside. So if I draw a line in between, it means this line must be going in between these two circles, but it must be a tangent towards, or tangentially attached towards the big circle, tangentially attached towards the small circle. Alright, so the basic rules will still be applicable. In other words, I have to join A with B. Once I've joined A with B, I can get the bisecting point, exactly the same as what I have had with the point or external tangent line. Now this one is internal. Again, I'm going to use the intersection point at C, and I'm striking an arc between A and B. So there we go with that. Now on the previous one it was external, so we subtract. So if you go to this one over here, it's internal. So internal tells me it's inside, it's small. So and I want to make it bigger in that case. So therefore I'm going to make it a little bit bigger. I'm going to total up the two radiuses with each other. So I've got one radius of 37, and I've got 17 on the other side. I'm going to total those two with each other and get an answer of 54. Now I'm going to set my compass on 54 millimeters and go back towards A. If I set my compass on 54, which is that size over there, you don't have to draw it all over around. You can just draw the arc until it intersects with this arc over here. So once I've got E, it points out to me the point of which I'm looking for if I connect A towards E. So that's the line I'm looking at there. Alright, so there we go again. I'll get the point at F. This is my angle I'm talking about. I have to get a line parallel to that, because remember the line will go through there. Can you see it will, coming from this side, go through that point, and it goes further downwards. So therefore it should have the same angle over here. So if I slide the set square from there towards B, I will also get an intersection point. And now these two intersection points can be joined with each other. Again, those two intersection points will make 90-degree angle with the line I've drawn from out B and from out A outwards. And that will give me my answer afterwards. So there we go with an internal circle inside between the two circles, and then with internal I have to of course total up or add up. With external I have to subtract to make it smaller. Internal I have to make it bigger. So therefore I'm totaling it up. Alright, so ladies and gentlemen, these two examples, and the first one, the three examples I've showed you was all with tangent lines. In other words, it's a straight line that's intersecting at a very small portion of the circle itself. Now what if I have to take these two circles and I have to draw an arc over here, and the arc must be placed in such a way so that it will only touch on one simple point, a single point there, and over there it also intersecting with that. Now of course we can take the compass and we can strike the compass towards the size of the arc, and we can try all over the paper and make lots of little holes in there to eventually find the end point from one point to another point. But now that's not the option, because the examiner is specifically asking by means of construction, so therefore I have to show the construction lines afterwards. On the end, if I give you an example like this one in the exam for instance, and you just simply draw the line from there to there, this exercise will basically count up to 10 or 11 marks in total, and you will be getting only 1 mark for that point and only 1 mark for that point. So you're going to get 2 out of 11 for that. That's not a pass. You have to show, you have to remember the constructions or what is necessary in order to get that point. And the same with the two arcs. In this case, external common arc to unequal circles. Right, so there's my two unequal circles. I have to go external. The word external tells me it's exit. So it's on the outside. So this arc should be on the outside. And this radius I'm going to use is 60. You can see this is 20 and this is 12 millimeters. The arc is 60, so it's quite a large arc that have to be fit in onto these 2 points over here. So now external, and we've got the calculations. We know that if it's external outside big, it's going to become smaller. So therefore, again, I've got a radius over here, and I've got a small radius, and I've got a small radius over there. So now, in this case, it means that if it's external, the arc should be on the outside. I have to subtract. I have to make it smaller, in other words. Remember, the arc I'm using is 60 millimeters. All right, so in that case, 60 millimeters minus 20 gives me 40 millimeters. So I can strike an arc here somewhere of 40 millimeters, which is 20 plus 20 in this case. All right, so that's basically what you will get there. Now, of course, I said it's external, and it's a common arc of 60. I've got my second option, my second circle over here. So in that case, it also means that I will have to take the arc of 60 and subtract 12 from 60, and that will give me 48 millimeters in total. All right, so now I'm going to set my compass on 48 millimeters. I'm going to put the needle, I'm putting the needle point on that specific point, and then strike the arc, which is 48 millimeters onto that part. Now I've got an intersection point, of course, over there. Now remember, the radius was 60 millimeters, so I have to reset my compass now to 60 millimeters, put the needle point at that specific intersection point, and then I strike the arc, and that gives me the external, outside, in other words, external tangent arc to two unequal circles of what you get there. Right. What you have to remember, external is big, so I have to make it smaller. So it's, what's the radius of what I'm going to use? 60 millimeters minus 20, 60 millimeters minus 48, and of course that will give me the intersection point on this point. Reset your compass on 60 millimeters, and then that will give me the arc that I will need for that one. Now, the last option of these types of options that I can show you is the internal common arc to unequal circles. All right, so again we have got unequal circles. Circles is not the same size, in other words. I have to draw an internal common arc. Now internal tells me it's inside, and that dimension I'm talking about is 25 millimeters. So in other words, I have to set my compass on 25 and find a point where I can put the needle point down where it will just intersect with one single point of that circle, and if I strike the arc further onwards, intersect at that point. Again, you can try until you get that point, but you will only get 1-2 marks for that. I'm asking for by means of construction, so therefore the examiner is predominantly saying construction lines should be kept afterwards. Right, internal tells me it's small, and I don't want to become even smaller than what it is on this stage, so therefore I'm going to total up. Now remember, the arc I'm using is 25 millimeters. The radius of one circle is radius of 20, so therefore 20 plus the 25 gives me 45. Set your compass on 25 or 45 millimeters. Put the needle point at A, because we're working with these dimensions. Put it at A, and then you enlarge up to 45 millimeters and you strike the arc. So therefore, there we go with the arc itself. Now we also have got circle B. It's internal, so it's small, so it has to become bigger, so therefore I'm totaling it up. So it's 25 plus the 12 millimeters over there. That gives me 37 in total. So there we go with 37. Set my compass on 37. Put the needle point at B, and from point B I will open up my arc up to this point at 37 millimeters, and I will strike the arc at that specific point. There's my intersection point. Now remember, I have to go back to radius of 25, because it's asking for a radius of 25. Reset your compass on 25. Put the needle point at C, intersection point, and at that point I will be basically then draw the circle or draw the arc that will tangentially very closely intersect with circle A as well as with circle B. Alright, and those are the steps. So I have had a line and two arcs or two circles. Then if it's external, I have to subtract. If it's internal, I total up. And in this case, I've got an arc that I have to draw, not a tangent line like the first example, an arc. And this arc should either be added or subtracted. When do I add? If it's external, I subtract to make it smaller. If it's internal common arc, I have to add. I have to total the two radiuses with the radius of the common arc, or the radius of the radius of the arc itself. All right. So that's the two methods that I will have. All right. Geometrical construction still. the arc through 3 given points. Alright, so what I've got over here is I've got point A, B and C. Now it is requested from me to draw an arc that will go through point A, B as well as C at the same time. Alright, so in other words, with one strike it goes through all 3 of those. Alright, now you can set your compass and you can try, you will be basically keep yourself busy for a whole afternoon in order to find it at that specific point. The easiest way is the following. Remember, it has to go through A, B and C. Alright, so join A with B and get the bisecting point, which is that point over there, and get a line somewhere on that line I will be using. Alright, join B with C, get the bisecting point of those 2 points and draw the line as well. So there we go with a common intersection point with those 2 points. Now if I extend my compass towards A and I can strike the arc, it will go through B as well as go through C. Alright, so that's basically a simple way. Just join A with B, and then from there on you simply just get the bisecting point, join B with C, get the bisecting point, and if you join those lines with each other with an intersection point and you stretch your compass open towards A, it will also be the same distance towards B, it will also be the same distance towards C. Right, so that is the one method. Draw a circumscribed circle. Now circumscribed tells me it goes on the outside. Now this is pretty much the same as the previous example. It's just that C is not in line with AB as what the previous example was. It is more to the bottom, and then it's still an external circle like the previous example. Right, what happened with the previous example? I've joined A with B, I got the bisecting point of that, so therefore there we go, A towards B, get the bisecting point. That's the exercise that you know of by now. What was the other example? I went also further onwards and I went joining B towards C and also got the bisecting point of that, so therefore we can say that is going to be the bisecting point, and I've got an intersection point at that specific point. Alright, now if I'm afraid that this is not perfectly 100% correct, I can also do it on the bottom. In other words, take C towards A and get the bisecting point, and now you can see it worked out perfectly, 100% accurate. Alright, so on that specific point I'm putting up my needle point of my compass. I'm going to stretch it open towards A or B or C, it doesn't matter, and I can simply just join those with drawing the circle around. Right, so exactly the same as the previous one. The only difference is this one is closer to each other, it makes it proper triangle. The previous one also made a proper triangle, but in this case this is the method that you're going to use. This is now for an external circle, the external exit outside. In other words, the circle is on the outside of those 3 points. Now I have to draw an inscribe circle. Right, so inside, inscribe inside, internal circle in other words. Alright, so there we go with that part. Again, I've got 3 points, A, B, C. I've got angles between A to B to C, and also C to B to A, and also from B to A to C. So therefore take that angle and I bisect the angle and I get myself a line. And I do the same with C. You know the method that was on the first part of this geometrical construction exercise. Alright, so there we go with that part. Now again I've got my intersection point. That's my intersection point I'm looking for. And at this specific intersection point I can now take my compass and I can stretch it open from that point onwards. Alright, so that is the internal circle, in other words, what I will need for this in this case. Alright, ladies and gentlemen, so those are the exercises I've explained to you. You can go to the EGD website and you will be able to see on the website there's some examples, some old exam papers on this specific topic. So you can go, you're more than welcome to go onto that website and then you can go and see what type of exam papers. Now, just remember, with this exercise, of course, we're not going to just bisect a line because that's very entry level. Alright, so we want to have to, in an exam paper, have to have low order, middle order and higher order questions. Now you can imagine that these 2, 3 or 5 last options that I've explained to you just now was basically the higher order questions that you could have expected in that case. But with the bisecting of a line, bisecting of an angle, copying of an angle, dividing a line into 5 equal parts or 6 equal parts. Those will be low order or maybe middle order questions that you can expect. It's not going to be per se high order questions at all times. The tangent circles, internal, external, tangent lines, internal and external, or from a point, those will be the more higher order questions because there's more steps involved, and it also needs some more skills in drawing arcs and circles in terms of that part over there. So those will be the middle and higher order questions that you can expect in an exam or a test at the beginning of the year. And this will also, like I said to you in the start of part 1, this geometrical constructions, both of these two parts, part 1 as well as part 2, will be forming part of the question paper number 2. Alright, so that's where it will fit in. At the end of the year, you will be writing 2 exam papers, paper 1 and paper 2. Paper 1 will consist of solid geometry, then from there on also some sort of for grade 10, more specifically solid geometry, 1-point perspective, and then also house plans. Now the house plans, the civil drawings in other words, can be either a formal drawing at the question 4 where you have to draw the section through a specific area, and then also there might be some symbols involved like windows and doors and so on. And then question 1 will be analytical question. Now, that analytical question will be all questions concerning line work, line quality, types of lines that you can get, where will you use some of those lines, also some civil drawings, and I'm asking you where's the foundation, where's the hardcore, where's the wall, where's the door, where's the window, those things. All right, so that will be the analytical question. And on question 1, question 4, also civil drawings, but more formal work drawings that will be involved in that part. And now with question 2 for grade 10 level, it will also be a mechanical drawing, in other words with a name block, for instance, who drew the drawing, what's the size of the drawing, what scale has been used, when was it approved, when was it printed, all those type of questions that you will get with a mechanical analytical question. I can also give you a drawing and then ask you some questions on that specific drawing itself. Then question 2 will consist of geometrical constructions. Alright, so now the geometrical constructions will be these part 1 and part 2 that I've showed you on this session as well as on the second session. And then your third question will be an isometric drawing at the end of the year, and your fourth question will be a mechanical drawing. Now your on grade 10 level, mechanical drawing will consist of a casting. Now what is a casting? A casting is 1 unit. It's something that has been melted into a mold, and if you take off the mold, it's 1 unit. It's not assembled yet, it's just 1 unit, 1 block in other words. Shaped to all different ends and so on, but that's the unit that we're talking about. Alright, so in that case, your question will be to take that unit and draw the front view, the right view, the left view, as well as the top view of that, of course in third angle lithographic projection. And that's also that needs to be explained to you on a later stage. Right, so ladies and gentlemen, yes, that is what you will get in terms of this session. This is more or less what you will experience in terms of geometrical constructions. I can ask you a combination. I can give you a drawing with all built up towards these type of questions I'm looking for and answers I'm looking for tangent circles, for tangent arcs, for instance, for external circles, for internal circles or arcs. And then also dividing certain areas, draw a solid continuous line from A to B, draw a center line from B to C, and draw a hidden detail line from C back to A, for instance, in that area. Those are the questions that can be asked. I can also ask you freehand drawings that can also be forming part of the first question, first paper, or the test that you will write in March, and ask you to draw a object, and then from that object I evaluate you on how do you use your freehand possibilities. Did you use a grid, for instance, or did you enlarge it to a scale, that you made it smaller to a smaller scale, or whatever the case might be. So those are the different questions, and what I want to point out to you, it can be asking all different combinations of questions. Go to the website, you will see plenty of old exam papers, and then from there on it will be visible. Now the website is on Great College Secondary School's portal or website, and then from there on you go to academics, and Moodle is the second step. From Moodle you choose simply Engineering Graphics and Design, EGD. If you click on that, you will see you will have grade 10, 11 and 12. You click in, you log in as a guest. You don't have to have a password for that. So you log in as a guest. Once you are in as a guest, then of course you can go to grade 10, and then all these topics, all these slideshows that I've pointed out to you, as well as these video clips that I've made, will all be there, and you can go through them yourself at your own time at home and work through those exercises. From now, just thank you very much for all your attendance at this stage, and then also for listening. I trust and hope that this will be a prosperous year for you in terms of engineering, graphics and design, that you will understand the content, and then also will be able to do the content in the exams, and be proud of your work. Keep it neat, keep it clean, and try to work and focus on your line quality. I thank you very much.